Okay, for example 2, we're going to be solving equations by rewriting them to have a common base. Given an exponential equation with unlike bases, use the one-to-one property to solve it. You're going to rewrite each side in the equation as a power with a common base. Number 2, you're going to use the rules of exponents to simplify if necessary so that the resulting equation has the form with the same base and the exponents either s or t. Number 3, you're going to use the one-to-one property to set the exponents equal, and then you're going to solve the resulting equation for the unknown. For example 2, we want to be able to solve 8 to the power of x plus 2 equals 16 to the power of x plus 1. First thing you want to do is you want to write 8 and 16 as powers of 2 because that can create a same base. So 8 is the same thing as 2 to the third power with an exponent of x plus 2. And 16 is the same thing as 2 to the fourth power with an exponent of x plus 1. And now what we can do is we can take our exponent inside the parentheses and multiply it by the exponent outside the parentheses. And now we're going to end up having the same base. So we're going to take the power of a power, you're going to multiply the exponents. So now it becomes 2 to the power of 3 times x plus 2 equals 2 to the power of 4 times x plus 1. And then we can distribute those numbers. So now we have 2 to the 3x plus 6 equals 2 to the 4x plus 4. And now we're going to use the one-to-one property to set the exponents equal. So now that we have the same base, now we can set our exponents equal to each other. So we have 3x plus 6, which is equal to 4x plus 4. And then we're going to solve for x. Solving for x, we can subtract 4x to both sides, subtract 6 to both sides, and dividing both sides by a negative, we're going to get x equals 2.